All right, so for this problem, we're going to do it on Excel. The first thing we need to do is figure out what kind of problem we have. This is very easy to spot just by looking at this mu1 and mu2 that we have right here. This means that we're doing a two-sample hypothesis test. We can also tell by looking at this question 38 right here, we see mu1 minus mu2. So that's a clear sign that this is a two-sample, right? Mu1, mu2, this two-sample, and it's a hypothesis test because it's asking for what is the null hypothesis, what is the alternative hypothesis. All right. So before we get started, let's write out everything that is given to us in this question. So we have a random sample of 22. So we're going to call this N1. So N1 is 22. What else do we have? We have an average training time of 62. So that's going to be X bar 1 of 62. We have a sample standard deviation. So this is really important right here. Sample standard deviation. So I'm going to put S for sample and put SD. So sample standard deviation 1. And we have, that's 10. All right. What else do we have? So we have another sample of 16. So that's going to be our N2, 16. X bar 2 is 65.4. And our sample standard deviation of 12.3. So SSD2, so sample standard deviation 2 is 12.3. Okay. So that is what we got. Now let's figure out the null and alternative hypothesis. That's the next thing that we should do. So typically in these problems, I've said this before, we're given the alternative hypothesis. Now, where in this problem is it? It's right here. I can just see it, spot it immediately. Higher. So we see higher. That means our alternative is going to be greater than. So that means our HA is going to be mu1 minus mu2 is greater than 0. And that means our H0, so our null hypothesis, is mu1 minus mu2 is less than or equal to 0. All right, so I'm actually going to move this right here. Okay. So we can just answer these right here. So our null hypothesis is less than or equal to, so that is D. And our alternative is greater than, so that matches with C. Okay. And just looking at this really quick, you can see that we need our standard error, our test statistic, and our p-value. So we're pretty much looking at the p-value approach. Okay. Now let's look at the case that we have. So what is our standard error? What is our test statistic? Let's first pause and let's look at what we got. So our case right here, I call these cases, is a greater than. We have a greater than problem where our alternative is greater than. So that matches with this right here, right? mu1 minus mu2 is greater than this value. All right. So before we can get our p-value, remember in our p-value, we need to plug in our test statistic. So we need to get our test statistic. You see how this bottom part looks kind of nasty, right? Like it's kind of a lot going on. We can do this separately to make our test statistic equation a little bit nicer. So this bottom part is also known as our standard error. So what I'm going to do is I'm going to calculate this part first, this standard error, this bottom part, and then I'm going to calculate the test statistic. And I want to point out right now that we have standard deviation 1 squared and standard deviation 2 squared. So what I'm going to do is right underneath here, I'm going to put SSD1, and I'm going to do that squared. So I'm going to do 10 squared, because that's what we're going to be using in here. This just makes it a little bit nicer. And again, I'm going to do that as well for this one. So square it. So to get our standard error, we're going to be doing the square root of our standard deviation 1 squared divided by our n1 plus standard deviation 2 squared divided by our n2. And we get 3.74. Okay, great. Now we can get our test statistic. So how do we calculate our test statistic? That is going to be x bar 1 minus x bar 2 minus value divided by your standard error. So the value is this 0. And for the purposes of this class, it's always going to be 0 for chapter 10. So this value is going to be 0. So you don't even have to do anything here. So it's just going to be x bar 1 minus x bar 2 divided by our standard error. So our test statistic is x bar 1 minus x bar 2 divided by our standard error. And when you do that, you get negative 0.908. All right. So the next thing we need to do is to get our p-value. Okay. So let's go to the p-value approach on our formula sheet. We have our, okay, so let's go to the, okay. So we have a right tail test, right? Our alternative is greater than. So right here, we can see we have a right tail test. Our alternative is greater than. So this is what we're looking at. Do we have population standard deviation? No, we have sample standard deviation. So that means we have to use this formula down here, 1 minus t dot dist. Okay, so we have our test statistic. That's great. We have that right here. But what is our degrees of freedom? Because this is a 2-sample test, we can't just do n minus 1. Which n are we supposed to use? So what we need to do is we need to use the template for unknown variances. So this is a template that you are going to be able to use on the exam. So I'm just going to bring that up right here. And what you're going to do is you are going to change these values to match what you have here. So what is our n1? Our n1 is 22. So let's change that. What is our x bar 1? X bar 1 is 62. What is our standard deviation 1? That's going to be 10. What is our n2? That's going to be 16. What is our x bar 2? 65.4. And what is our standard deviation 2? That's 12.3. And you see that this number changed. Our degrees of freedom is 28. So I'm going to put this right here. DF is 28. So I just want to note right now, say this one more time. Whenever you have a 2-sample hypothesis test, whenever you're doing a 2-sample hypothesis test and you have sample standard deviation, you have to use this template for unknown variances to get your degrees of freedom. Okay, well, we got our degrees of freedom. We can minimize this. And now we can solve the problem because we have the test statistic, we have our degrees of freedom. Okay, so we are going to do equals 1 minus t dot dist. What's our x? Our x is our test statistic. What is our degrees of freedom? Our degrees of freedom is 28 and comma 1. To do that, and we get 0.81. So now we can go and answer these questions. So 40, what is the standard error? That's right here. B. 41, what is the value of our test statistic? We calculated that here, so that matches with C. And what is the p-value? P-value, let's write this here, our p-value is 0.81, so this one. And that's how you do this problem. For these problems, you just have to do a lot of practice. Practice, 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 be able to identify which case you have. And then I feel like this formula sheet is all you need to be able to do this stuff.